Hi everyone, welcome back to Power Electronics session 3. We discussed in the previous video about single phase half wave and full wave rectifier and corresponding formulas. Now we will concentrate on three phase half wave and full wave rectifiers for the source inductance and respective formulas. Okay, so if you look at the three phase half wave rectifier, it will have three thyristors which are connected to the respective sources through the source inductance. And load will be connected between neutral point and start point of the load. And in this case also, load current will be constant and it will be maintained at level of I0. As we discussed in single phase, here also we will have the three respective formulas. One will be I average. I average will be VML divided by 2 omega Ls into cos alpha minus cos alpha plus mu. So here the difference is only line voltage maximum. Okay, respectively, the rest of the thing will be the same. Then back to V average. As I told you that V average can be represented in two ways. One is with mu and without mu. If you want to represent with mu, as I told you that we need to replace the cos alpha with cos alpha plus mu divided by 2. If you look at this one, you can see without source inductance, V average in case of three phase half wave rectifier with continuous load current is 3VML divided by 2 pi into cos alpha. Now cos alpha is replaced with cos alpha plus mu by 2, then it becomes 3VML by 4 pi into cos alpha plus mu. Same thing we can represent without mu. Then in that case, we need to look at the drop across the inductance. So now look at here, V average will be V average with source inductance will be without source inductance V average, that's nothing but an ideal rectifier 3VML by 2 pi into cos alpha minus instantaneous voltage across the source inductance, that's a omega Ls I0 divided by time period to get the average value. In case of three phase half wave rectifier, time period will be 2 pi divided by 3. That means 3 comes to the numerator, then it will be 3 omega Ls I0 by 2. So these are the formulas we need to remember for three phase half wave rectifier. As we discussed in case of single phase system, here also we need to look at conduction angle of each thyristor. Conduction angle of each thyristor will be generally in case of ideal rectifier with continuous current conduction will be 2 pi by 3, that means 120 degrees. Now if you consider the source inductance, then we need to add mu. It will be the same thing even if you consider the diode rectifiers. So that's what we need to remember. Then move on to the three phase full wave rectifier. If you look at the three phase full wave rectifier, we have 6 thyristors and respective legs are connected to phases through source inductance. Here also load current will be constant at the level of I0 and voltage will be appear across the load with the source inductance is represented V average Ls. So I average will be as same as the three phase half wave rectifier, no difference, but V average will be the different one. So V average without V average with the source inductance in terms of mu will be 3VML by 2 pi into cos alpha plus mu. So the difference between the half wave and full wave is only division, that's nothing but there 4 pi, here 2 pi, that's only the difference. Then move on to the without next formula without mu. Here it will be ideal voltage across the load in case of ideal source, there's nothing but 3VML. Sorry for this mistake. 3VML by pi into cos alpha, that's ideal average voltage, minus drop. Drop is, as I told you, that it will be instantaneous voltage drop across the inductance divided by time period. Here omega Ls I0 will be the instantaneous voltage drop divided by time period, means in three phase full wave rectifier time period will be pi by 3. So 3 comes to the numerator. That's the meaning of that. Okay. Again here we need to look at the conduction angle of each thyristor. That will be gamma t equal to, in 3-phase full rectifier, each and every thyristor will be in conduction for 120 degrees. That is nothing but 2 pi by 3 if you consider the continuous current conduction. Now if you consider commutation, then it will be mu. So then we will see that it will be increased by mu angle. So these are the formulas we need to remember for 3-phase half-wave full rectifier. Okay, so with this, whatever we discussed in the previous class in last year, that's completed. Now we will look at that some gate questions which are based on the source inductance. Okay, so with that I will close this video. Then we will talk about next sessions, like the next lessons based on your feedback and your experiencing any problem to understand or something you want to know. Then we provide that. Okay, then move on to the gate questions. If you look at here, like gate question will be, you can see that it is given in the last year gate exam. That is like in the circuit shown, the diodes are ideal, the inductance is small, and average load current is not zero. This one, which one of the following statement is true? Okay, before going to look at the options, you can see that which rectifier is given here. It is practical rectifier because the source inductance is there, and it is a diode rectifier because both are diodes. That's why, as I told you, like commutation will also be happen in case of diode rectifiers. The main difference between the diode rectifier and thyristor rectifier is only the alpha. Okay, so that's what we need to remember. Then we will look at the options what they have given. So option number 1, diode D1 conducts for more than 180 degrees, D2 conducts for more than 180 degrees. Then D2 conducts for more than 180 degrees, D1 conducts for 180 degrees. Next one, D1 conducts for 180 degrees and D2 conducts for 180 degrees. And fourth option, D1 conducts for more than 180 degrees and D2 conducts for 180 degrees. So I don't know whether you remember from the previous, I can say like session number 1, we discussed like 2 points with respect to the effect of the source inductance. One is like a conduction of each and every device will be increased. If you remember that statement, then obviously you can answer this question. Okay. No sir, we are not able to get that one. Then you need to look at the single phase half-wave rectifier with thyristor controlled. If you look at that one, what we discussed here, you can see that this is a single phase half-wave rectifier with thyristor. Now I just told that the difference between the thyristor controlled and diode controlled rectifier is only mu. So that means this is also replaced with the diode. Then you will see that these formulas will be applicable to the diode rectifiers by making alpha 0. If I am making alpha 0 means you can see that conduction angle of this diode D1 and diode D2 becomes pi plus mu, pi plus mu. That means if you look at this option, both the diodes will be conduct for more than 180 degrees. That means this option is right one. Okay, so that is what the correct option. So remember that. Okay, so move on to the next question, which is given in the one of the GATE exam. You can see here the figure below shows an uncontrolled diode bridge rectifier supplied from a 220 volts 50H single phase source. The diode draws a constant current I0 14 ampere. the conduction angle of the diode D1 in degrees is. So this one. So here source inductance is given. Again, this is the practical rectifier, and load is drawing a constant load current of 14 ampere. Don't confuse with the current source, as we discussed in the previous classes. Constant source current current source indicates that load is drawing the current of 14 ampere. That's the meaning of that. No need to worry about that one. Okay, again this is the diode rectifier with source inductance. Now we need to calculate conduction angle of the diode D1. So if you want to know like what is the conduction angle of the diode D1 or D2, D3, D4, as we discussed in the previous session, conduction angle of the diode or thyristors in case of bridge rectifier will be same. That is nothing but conduction angle of the diode is pi plus mu. So pi means 180 degrees, we already know. So then we need to calculate what will be the mu. So to calculate the mu, we have different formulas. We can use any one of that to calculate mu. So for simplicity, we can easily consider I0 bar. Okay, single phase bridge rectifier, I can say. So what is that one? So if you look at here, I0 equal to Vm divided by 2 omega Ls into cos alpha minus cos alpha plus mu. This is what we discussed in case of bridge rectifier with the thyristor control. Okay, now this is given as a diode rectifier. That's where, as we discussed already, alpha need to be modified. Alpha should be 0. In that case, this modified equation I average will be Vm divided by 2 omega Ls into 1 minus cos mu. So we need to calculate what will be the mu. Okay, so for that we need to substitute all the things whatever it is given here. So I average is given, that's a 14 ampere. So 14. Vm is given in terms of RMS value. So 220 into root 2 by 2 omega. Omega means 50 Hz is given. So 2 pi into 50 into inductance is given, that is 10 millihenry. So 10 millihenry means it is 0.01 into 1 minus cos mu. Now if you take out the cos mu out, it will be 1 minus this into, that means 40 into 2 into 50 is nothing but 100. 100 multiplied with 0.01, that means it is just becoming 2 pi only. Okay, divided by 220 into root 2. Okay, so then again further simplification, 1 minus 0.2827, then mu equal to cos inverse of 1 minus 0.2827, that is equal to 44.17 degrees. Now conduction angle of the diode, each diode in fact will be gamma d equal to 180 plus 44.17 degrees. So that means answer to this question is it is 224.17 degrees. So that is answer for this one. Okay, so again I'm telling that you need to look at that what rectifier is given here and what is the source. Source is actually non-ideal, that means inductance is given, and rectifier is given diode rectifier. That's where we need to modify our formulas. Okay, our formulas we need to modify means, as we discussed already, this is a fully rectifier with thyristor control. That means the same formulas we can take, but we need to consider alpha is 0. So this is what we have taken with alpha is 0. So if alpha is 0 means Vm by 2 omega Ls into 1 minus cos mu. That is what we actually consider here. So then we need to substitute whatever the things are given and find out the mu. As we discussed, conduction angle will be pi plus mu. That's why we are getting this sum. Okay. So with this I'm stopping here and we'll discuss the remaining things in the next session.